All right, good afternoon, everyone, and welcome to NASA Glenn Research Center's Plum Brook Station. I would like to thank you all for being here. We have some special guests with us today that's traveled from out of state and even overseas. Special welcome to a bunch of folks that are on the panel here today, all of them for participating, our distinguished guests who you hear from in a few minutes. I'd also like to thank General Stringer, Lori Manthe, and the entire team for their work in getting us here for this incredible event here today. Thank you so much. I'm most happy that it's sunny outside and not snowing, that we were all able to make it here without really any weather-related issues. Let me first recognize a special person we have with us here today, and that's Congresswoman Marcy Kaptur, representing Ohio's 9th Congressional District, which includes both Plum Brook Station and Lewis Field, parts of NASA Glenn Research Center. Welcome. We'll be hearing from Congresswoman Kaptur here shortly. We have several other folks joining us today, elected representatives or their staff. Josh Thurston from Congresswoman Kaptur's staff, Karen Kandisky from the office of Senator Rob Portman, Daryl Kick from the office of Congressman Bob Gibbs, Ryan Dilworth, also from Congressman Gibbs' staff, Thomas Queen from Congressman Renace's staff, Bianca Coop from Congressman Bill Johnson's staff, Steve Arndt, Ohio State Representative, and we thank you all for being here today as well. Today's a special day. We welcome Orion European Service Module to test here at NASA Glenn. The ESM and its tooling arrived in Ohio about 2 weeks ago. Since then, the incredible team who has assembled with us here today has been working nearly around the clock to prepare for that next testing cycle that's about to start. This testing is absolutely crucial to ensuring the successful flight of the next generation of human-rated spacecraft, Orion. That is really what NASA Glenn's testing capabilities are really all about, ensuring that mission success, and that's our job, and that's what we've heard from Mark and the Orion team. For those of you that have not been here before, Plum Brook Station is home to several unique test facilities, one of which you're in today, the Space Power Facility, containing the largest vacuum chamber in the world and capable of testing all manner of articles and hardware in a simulated space or planetary environment. Other facilities here also include our Space Propulsion Research Facility and our Hypersonic Tunnel Facility, each providing testing capability that gives NASA and its customers, one of which is Orion, the ability to buy down that risk that each mission needs to, reduce schedule, and reduce mission cost, but most importantly, deliver humans safely to orbit. By discovering issues in a controlled testing environment on the ground, we can correct those issues before launch rather than after, when there's less we can do and at a far greater cost. Throughout NASA Glenn's history, a history that in this January will mark 75 years, we've been on the cutting edge. First with aeronautics technologies during the war, which not only led our country into the jet age, but eventually into and through space. This legacy of helping develop technologies that allow us to explore the deepest regions of space lives on through the testing that will take place right here in a few short months. NASA Glenn's expertise has been instrumental as part of the agency team working on Orion in developing many of Orion's systems with our partner centers, including structures, mechanisms, pyrotechnics, propulsion, thermal protection, materials, power, and avionics. This testing will be NASA Glenn's most recent contribution to the exploration program of this nation. Orion will be used to reach destinations throughout the solar system, a capability no other spacecraft in the world possesses. And thank you again for being here. At this time, it's my honor to introduce Congresswoman Marcy Kaptur.
Director Free, ladies and gentlemen, thank you so much for being here today to be a part of witnessing history and building the future. The other night, when the moon was full, I just stood outside at night and I looked at it. And I thought about when I was born versus now, and how much more we as humans know about the Milky Way galaxy and points beyond, and how much more we know about how to even look at our own planet suspended in that space. And this facility today, because of the work of Director Free, his predecessors, General Stringer, all of the scientists who too often remain nameless, who give their lives to this, the countless hours spent in labs and trying to figure out how to make the math work and the science work. Not a lot of publicity, but nonetheless truly creating a more enlightened future for all of humanity. I want to thank, as I look at that wonderful rendering there, I want to thank our European guests who have traveled so very far to be with us today. We share a fraternity and love of liberty and of the enlightenment that transferred its great power here to the United States. And to be united with our European allies in this great quest is truly a remarkable and important undertaking. I want to also say, for those who may not be from this region or may be listening from points near and far, there is no other place like this on Earth. This testing facility is rare. It has taken millions and billions, literally, of dollars to construct, to anticipate. The testing that will be done here on this module, I was asking Director Free, compared to what's been done before in this module, how much more sophisticated will this particular testing be? Give me a number. Well, he didn't want to commit himself to exactly a number, but it's geometrically greater than anything that's been tested here before. Maybe 20 times, maybe more than that. And so when we think about what took all of you working together, many who aren't here today, to help us probe with this life support system, which is what it is. We thank those in Europe for partnering across several nations with our own. And I know that when Orion is both tested and ultimately lifted with a full payload, that the world will cheer. And we know that the people here will have done it. It's so marvelous to be here with representatives of my colleagues from the Congress, Congressman Gibbs, Congressman Renacci, Senators Brown and Portman, who have also traveled far to be with us today. Did I miss anyone? I hope not. To know that you have our support, and we are very proud as Buckeyes that this testing will be done here in the great state of Ohio. Congratulations to all. We are very proud of you, and we all stand at Liberty's side as this moves forward. Thank you so much.
Thank you, Congresswoman Capter. Good afternoon. I'm Frank Jennings of the NASA Glenn Communications and External Relations Office. I will be your moderator for today's program. Joining us on stage is our panel of representatives from each of the Orion program partners involved in the testing that is being conducted at the Space Power Facility. They are Mr. Jim Free, NASA Glenn Center Director, Mr. Greg Williams, Deputy Associate Administrator for Human Exploration and Operations, NASA Headquarters, Mr. Mark Kirisich, Orion Program Manager, NASA's Johnson Space Center, Dr. Mike Hawes, Lockheed Martin Orion Program Manager, Mr. Nico Detman, European Space Agency Head of Development Department, and Dr. Oliver Eukenufel, Airbus Defence and Space, European Service Module Program Manager. At the conclusion of the panel's remarks, I'll open the floor for questions from the media representatives in the audience, as well as those who are joining us online through social media and on the phone. If anyone is following us on social media and would like to ask a question, you can send your question to #AskNASA. I'll provide additional details concerning the media portion of our program once we arrive at that point. But before we hear from our panelists, we have a short video we would like to show. At this time, we'll begin with our first panel member, Mr. Jim Free.
Thank you, Frank. Good afternoon again, everyone. That's a great video to watch. Simple, right? That's it. A couple minutes. We flew out and back and landed, no problem. That really is just looking forward a couple years of where we're going to be, and that's why we're all here today. This is another stop along that journey, the journey of this team, now international team, designing a vehicle that's going to carry humans farther than we've gone ever. And that's an agency team, many partners across, some of which you see from the NASA side. We also have Dr. Ellen Ochoa here from NASA Johnson, who's an incredible partner leading this from a center perspective, and a great partner to me personally here at the center. So thank you very much for being here, Ellen. The testing that's going to take place here in the Space Power facility over the next years is really about ensuring that success of EM1. The building houses the world's the largest and most powerful and capable testing facilities. It's the only place you can test a vehicle of this size, fully deployed, in its launch and in its space configuration, which is so important in ensuring that mission success. It starts first, it's great to be able to look through this entire facility end to end. You don't get this view that often. And at the other end is a mechanical vibration facility, which takes that hard-mounted vehicle and shakes it to induce environments stronger than any other in the world. At the far end, the reverberant acoustic test facility, capable of up to 163 decibels, which is equivalent of 20 jet engines firing simultaneously. Our engineers, the European Space Agency and the Airbus engineers will simulate that launch environment to get those vibrations in the vehicle to understand how good is our design. And then the space simulation vacuum chamber that you see nearest to us, 100 feet in diameter and 122 feet tall, more capable than anywhere in the entire world. That's where we'll simulate what space is like for the vehicle. It's really that one-stop shop to come to for environmental tests on this scale. The vehicle will go through multiple locations during its testing and getting qualified for flight. And for us, that just means we did our job right and tried to figure out all the problems we could on the ground, which means we need to test the way we're going to fly. In addition to the vibration, acoustic, and space environment capabilities that are here, the solar array deployment is going to be done here, which means we're going to fire pyrotechnics to simulate the deployment of those solar arrays, to also simulate separation from the launch vehicle and the shocks that induces into Orion. And all of this testing, again, it's about ensuring mission success, making sure we built it well, making sure our ultimate goal, which is crew safety and meeting those flight requirements and our mission requirements. That testing is going to identify any risks that we haven't gone through, any design problems, any potential failures right here in a controlled environment on the ground. And that's the best place to find those issues, is before we're in flight. And it's all about the success of EM1. That's what we're focused on right now. The Orion service module provided by our partners at the European Space Agency and Airbus. We are very excited. Congresswoman Capter talked about the international partnership. We're building on international partnership built by the ISS that's flying today. That's where we come from and the strength that we rely on to fulfill our goal in developing the testing for this vehicle. We're very proud of our role in that mission here at NASA Glenn. Proud to be part of the team. I've been fortunate to be associated with Orion for a long time now, as Mark said this morning. I'm not going to say how long. But we're proud to be part of that. We're proud to be part of that here in Ohio, and especially at NASA Glenn. So thank you again for being here.
Well, good afternoon. I'm Greg Williams from NASA headquarters. I'm sort of the obligatory headquarters guy on the panel. You got to have a headquarters guy when you do something like this. But I'm really pleased to be here to be able to congratulate the whole Orion team on what is really a significant accomplishment in the program, the delivery of ESA's structural test article for the service module. The delivery of the SMSTA here today is really a substantial milestone in the program, and it really represents two things in my mind. One, as Jim mentioned just a second ago, is what it represents in terms of the international collaboration that is involved in this whole human exploration endeavor. You hear a lot of folks say that we need to do international collaboration because no one nation can afford to do space exploration on its own. And that's probably true, but what's more important is that we don't want to go alone. We want to go as an international partnership. We would love the human exploration endeavor to be a global endeavor. It says a lot about what we want to accomplish as humanity. It says a lot about what we want to accomplish as a people. And so we're excited about this international collaboration. Jim mentioned the International Space Station Partnership, which has been extant for some time. I was privileged to be part of that international agreements negotiating team for the very first round for the International Space Station. And so I have a sense for how challenging those partnerships can be to form and carry out, but also how rewarding they are. And what it is that we can accomplish together, and all the world can look and wonder at what it is that together we've accomplished. And they're going to see the same with Orion. They're going to see the same with the Exploration Systems Program. So the international collaboration that the STA represents for us is huge, and that's one of the reasons why I'm privileged to be here. The other thing it represents is the tremendous progress this whole program is making. Right, the whole Exploration Systems endeavor, Orion, SLS, the ground systems, is not a paper program by any stretch. We're wrapping up the design phase. We're building hardware, we're delivering hardware, we're testing hardware, we're fabricating, we're writing software, and we're putting the pieces together. And it's really exciting to see. You're going to hear from Mark Kursich and Mike Hawes about Orion and its progress in that context. Also wanted to point out while I'm here that the other pieces are also coming together under the leadership of Bill Hill and Tom Whitmire, who are here, who are leading so effectively this exploration systems enterprise. The Space Launch System program is making tremendous progress. There are core stage tanks being welded together. There are many elements of the program being fabricated. There are RS-25 engines being tested. There's now a new contract in place to start that production line again. So tremendous progress in the SLS program. Similarly, in the ground systems program at the Cape, the vertical assembly building, that iconic huge structure, is being re-outfitted with a whole new interior structure to accommodate SLS and Orion processing. The pads are being refurbished. The mobile launcher is being refurbished. There's a new fire control room. All these are evidences of real progress that the whole exploration systems enterprise is making, and it's really exciting to see. Bill Hill has hired an EM1 mission manager to choreograph all of these pieces coming together, and you'll see at various times in different presentations NASA folks make a view of progress from the top of the stack going all the way down to the bottom. All that to say is what that's pointing to is we're on this march to EM1. It's just a few short years away, and it's really exciting to see. And the ESA service module structural test article is the first tangible evidence of that you get to see here at the Glenn Research Center. And so I just like to close by congratulating again the whole team, the Orion program at NASA, Lockheed Martin, our European Space Agency partners. Really is a significant accomplishment, and we're looking forward to seeing more to come. Let me turn over to Mark Kirsten to talk about Orion and the progress they're making in general. Thank you.
Thank you, Greg, and welcome. Thanks to everybody for joining us here today. We in the Orion program have the great opportunity and also the great challenge of building the spacecraft that's going to take humans farther than we've ever gone into space before. And at times it can get hard. To borrow from the Congresswoman, at times it's hard to get to math to work and to close together. But in Orion, we're very fortunate that we are able to employ some of the best, brightest engineers and scientists from across the agency, from industry, and literally in this program now from around the world. And that's really what we're here today to do, is to celebrate the accomplishments of two of Orion's most important partners, the Glenn Research Center and the European Space Agency. I'll start with Glenn, and I'll start with a story. When I joined the Orion program many years ago, I'll be like Jim and I won't quote the number. The very first person that called me when I joined the program and welcomed me into the program was Jim Free, who's now the Glenn Center Director. At the time, he was the service module manager for Orion. So Jim's been with the program for a long time, and he's held a number of jobs since then. But what I can tell you about Jim and about really everybody that we work with here at Plum Brook and at the Glenn Research Center is they work tirelessly to help make Orion successful. And Jim, we really appreciate that. And really nowhere is it more visibly and tangible to see the results of this hard work and effort than at this test facility here today. You're going to have an opportunity later to walk through the building. You'll see this large thermal vacuum chamber. You'll see the vibration table. You'll see the acoustic chamber. And these are world-class facilities. There is nowhere else in the world that you see facilities like this. And Jim talked about they're really important because when we launch on the world's most powerful rocket, we are going to be shaken and vibrated, and we have to make sure we can survive that. When we're traveling out to deep space destinations, as you saw in the video, we're going to see thermal extremes. So we have to put our spacecraft through all that testing to make sure it's worthy of carrying human beings on this mission that we're about to undertake. So Jim, thank you, and I really appreciate everything that the people here have done to get us ready for this testing. I'd also like to recognize our European colleagues. It was just 3 years ago in December of 2012 that we signed an agreement and formally welcomed them into the Orion program. And I wanted to talk a little bit about the function of the European service module. It's a really important piece of hardware in our spacecraft. First of all, it's propulsion system. It provides the translational capabilities, attitude control, and during ascent, during the highest parts of our ascent, it gives the spacecraft an abort capability should we have a contingency going uphill. In addition to that, it has very large solar arrays. It generates the electricity that powers all of the equipment on board Orion. It has radiators that overthrow heat and keep our equipment and the humans inside the spacecraft nice and comfortable. And it also has gas tanks and water tanks to provide the air the crew breathes and the water that they drink. So as you can easily understand, the European Service Module is a critical element of Orion, and we really need it. We aren't going anywhere without it. And then that's why today is such a great day, because the piece of hardware right behind me, the beautiful piece of hardware, is a sign of the progress. And over the 3 years, it shows the commitment that the European Space Agency and their contractor team has to this program to deliver this article when they did. So Nico, to you and Oliver, and also to our TASI colleagues who are today, I want to thank you and express our appreciation for what you're bringing to the program. So thank you. We before I introduce my industry partner, I did want to talk a little bit about the progress Orion is making around the country in addition to these locations. Most notably, down in Louisiana, right now as we speak, the Exploration Mission 1 crew module, the crew module that will be on its way towards the moon in the video you just saw in just 3 years from now is almost complete. We'll complete it in early January, and from there we ship it to the Kennedy Space Center, where the Lockheed factory is located on site for being in the production and outfitting phase. And what we have now is a short video that shows you some of this progress around the country. Thank you, and I will hand off to Mike Hawes. Mike is my industry counterpart with Lockheed Martin.
Thanks very much, and thank you all for coming out. As Mark said, Lockheed Martin is proud to be NASA's industry partner as the prime for the Orion spacecraft, but that gives us a special role in relation to the European Service Module as well that I'd like to talk about. But first, I'd like to think that it's a little surprising to me when we think back that this Saturday is actually 1 year from EFT-1, our first test flight for Orion, and it's hard to believe that it's gone that fast. But usually I tell my team to keep their heads down in color. And keeping our heads down in coloring is what has given you the Orion scenes in that movie. We actually have the next crew module in New Orleans. There are 7 welds of the aluminum structure to build a crew module. 5 of the 7 have been complete, and we're looking at the next one the end of this week or early next week in terms of continuing on the build of that spacecraft. We're also delivering computer boards, secondary structure, interface cards that we're working to deliver to our ESA colleagues, work going on across the country. And so it's really exciting to see that much work coming together and new equipment being produced, but now being produced with this international partnership. As Greg mentioned, we all believe that exploration has to be an international venture. We're very proud that Orion is the first piece of that international cooperation, and so we work regularly. On the general side, we support the NASA ESA partnership, but very specifically, we work day in and day out with Oliver's Airbus team. And while it's a little challenging, you can't go down the hallway to talk. Airbus has folks in the United States working with us. We have folks in Bremen working regularly with Oliver's team. And so there's a lot that we are able to accomplish, the two teams working together. One of the things that I wanted to really give you a sense for, and Mark touched on it in a couple of examples, but I want to take those examples just a little bit further. There's so much capability in the service module, but that all has to be totally interactive with what's in the crew module. So these are not modules that you can just bolt together and say you're good to go fly. You have to demonstrate all of the interfaces, all of the capabilities. The solar arrays that Mark talked about power the entire vehicle, not just the service module, but the crew module. In fact, they feed the batteries in the crew module. And commands in the crew module through the computers tell the solar arrays which directions to turn to optimize the sunlight. Just as in the data connections, when we're firing the engines that Mark talked about, the guidance navigation system in the crew module is actually determining which engines to fire, how long to fire, and feeding those commands across the interface to the ESA service module. So very complicated and complex interactions, but things that just have to absolutely be tested and demonstrated before we fly. And this work is really the first step of doing that integration and that test. So it is a pleasure for Lockheed Martin to be a part of this team, and it's a pleasure to be working in a very collaborative manner with ESA and with our Airbus industry partners. And with that, I'll turn it over to Nico for the ESA perspective.
Well, thanks of all for the warm welcome. Everybody was talking so far about proudness, and I can tell you that also ESA is very, very proud having been selected as partner for the largest US exploration program. And I mean, this piece of hardware we are developing is a very significant one. So it's not only an honor, but it's also a burden. And the last 3 years of cooperation have been tough, were a big excitement. And I want to make a big compliment to all teams involved, to the European industry, but also to Lockheed and NASA, who have helped to bring this piece of hardware after 3 years to here. The implementing arrangement has been signed already 3 years ago. And who knows what that means, this piece of hardware, to deliver that in 3 years, that's a real team achievement. The Atlantic between us has not always helped, but I must say I've seen over those 3 years a tremendous development in the cooperation of the teams, and this is confirming the successful continuation of what the teams have already done in frame of the ISS program. I believe that Europe has also deserved being selected for this cooperation because we have a good track record in the cooperation in the ISS in frame of 5 successful ATV missions. But I would also like to say, what does it mean, this cooperation for ESA? This is the first time ESA is embarking on a human mission beyond low Earth orbit. And this clearly fits into our strategy. And I can only repeat, we are very happy being on that cooperation. And we are very committed to deliver on time. And with that, I can hand over to Oliver. Thank you.
So it sounded like I'm the one who's supposed to deliver on time. I got that message. But prior I start elaborating a little bit on my perspective, let me thank you first, Jim Free, General Stringer, for the hospitality, not just for today, but for the last weeks and for the months to come. Because what we don't see in this room is that Thales Alenia Space, our partner, Airbus Defence and Space, we're having people here. We're going to live in Ohio, in the vicinity of the facility, to work here for the next months. And this shows how much integrated this work is today and how it must be. Without that integration, starting in Europe and then going over here into the US, it would simply not work. We have a lot of experience in building for space, and many, many times we've been in charge of the vehicle to build, which means that we're used to being the system prime. In this program, we are the partner of Lockheed Martin, building for the agencies. And you can have different perspectives on that. You can have the perspective Europe is building for the US, or you can have the perspective that a joint industry team is building for agencies. And I think it was Mark Geyer about 1.5 years ago, where he was mentioning in front of the whole team that what he's expecting us to do is that we get our stakes together and we fix issues on technical level, independent of boundaries and of company boundaries and of agency or national boundaries, and then we report into a joint management team. And I think this is the key. You can see it either Europe with or against the US, or you can see it to select the right people and the right partners to work on a topic and then deliver against the expectations. And this is what we are doing every day. And I tell you, we must do it like that, because such a vehicle you couldn't build in a different manner. We've heard it already. In a nutshell, our European service module couldn't fly alone. It is missing a little bit of intelligence, so we're not having an onboard computer. We're having a lot of actuators and things that we can execute. But the whole mission control is done, first of all, in the crew module, which is delivered by Lockheed, and then, of course, by NASA for the overall mission responsibility. So NASA cannot fly without us, we cannot fly without them, which basically means you have to find solutions. And this is the basic prerequisite for designing an optimum vehicle. And without designing for an optimum vehicle, you will never fly the moon or beyond. So you see, it's got to happen. And what I see in the teams worldwide, that is just amazing. I mean, we know what it means to collaborate. Airbus Defence and Space is everywhere in Europe. It's worldwide, even in the US. But collaboration on such a daily basis requires a lot of effort from everybody. So, Mike, you mentioned that already. I'm not sure what is the most costly on this program, the telephone bill for our teams or any of the hardware you're seeing there. It's a great effort, and thank you very much to everybody who's involved in that. Now, for us, and also for you, if you take a look at the European Service Module, it is really the first of its kind. It's called a structural test article, but it is the first European Service Module, and it's got to be like that, because the way how we are testing here is testing for flight. And if this is not flight representative in materials and the way how we are producing that, then you will not get the message out of the test that you need. So it's still missing a little bit, like all the electricity, the electronics component, which we are developing and manufacturing in parallel to this. But the majority of the mechanical representation you see behind ourselves. And this is therefore our first milestone to go and embark on the long-term Orion program. And I can just say for Airbus Defence and Space, but as well for our partners, be it Thales or be it RUAG, out of all the European countries who are participating to this one, for this, space is in our DNA. And if you want to find one program where you can really have the pleasure of tasting that, that is the Orion program. It's the best place where we can be, and we want to be in there for a very long time period. And thank you very much for all the one who are participating here or sitting here that we are allowed to participate to that.
This concludes the remarks portion for the panel, and I will now open the floor for questions from the media representatives that are joining us. Because of time constraints, I can only accept questions from media. I'll rotate between... I'll rotate the questions between those coming from the audience and those that are being submitted online, again at #AskNASA, and then we will also go to the phones if we have questions. For those media reps in the audience, please raise your hands and someone with a microphone will come to you. Before you ask your question, please state your name and the organization you're with, and then we'll proceed. First question, sir.
I'm Jim Blue with WNWO TV, NBC 24 from Toledo. Welcome.
Hi, Jim.
By the way.
Welcome.
And this is for Mr. Free, if I could, please, sir. A lot of folks in our area don't know this facility exists. They know Sandusky is the home of Cedar Point, where they go to ride the roller coaster, but they don't know the big roller coasters are really built here, or at least tested here. Could you reflect a little bit on what this facility means to this community?
Yeah, I actually think Cedar Point is second to us, so it's not everybody thinks that way. I think it's a great, as I say, for all the 9 NASA centers, every community that has a NASA center, a NASA field site like this is for us at NASA Glenn, should be proud to have it. This place is part of the legacy of what's flown in space. The testing that has occurred here to date for the radiators on the space station, the way we dump heat on the station today is because of the radiator testing done here. The launch vehicle fairing testing that has been done here has served to launch scientific spacecraft and national security payloads. And the fairing that will shroud the James Webb Space Telescope was tested here. So it should be an element of pride. That's what it means, is this place is part of the space program in years past, and with what you see here today will be part of the space program in years to come.
Next question. Gentleman in the second row.
It's not working. Yeah, it's working. Good afternoon. My name is Arjen van der Horst. I'm from Dutch Radio and Television. I've got a question about the long-term ambition. You showed what's ahead of us. You're gonna, in 2018, we want to go to the moon. But of course, the long-term ambition is Mars. Are you already thinking ahead? Because a surface module like you have now is not enough to bring people to Mars. You need something where people can live in. Is something being designed already? Are you thinking ahead?
I'll start and ask others to comment. Short answer is yes, we are thinking ahead. We call the 2018 flight EM1 because there's going to be several after that. The whole reason we're going to the vicinity of the moon is because cislunar space, that volume of space around the moon, serves as a great area not only to practice deep space operations, but also as a staging area for which we can send future missions to Mars. And so the first pieces of this are SLS and Orion, and including the service module that you see behind you. Subsequent pieces are going to include a habitation capability, which we'll need in deep space. Where we'll also need in-space propulsion capabilities. We're going to be demonstrating that with the asteroid redirect mission, which is planned for 2020. That's going to provide us a bus, a ability to move large cargo masses in long distances in deep space. So that's underway. Then we'll also need entry, descent, and landing capabilities through the Martian atmosphere. There's a number of technologies that are being developed, funded and sponsored by a sibling directorate, the Space Technology Mission Directorate, to take on that piece of it. Some of those technologies are being done here at STR Glenn. So we are thinking ahead. There are a lot of pieces in place. There are technology development activities underway for all of those. A number of those are also technologies in which we're in discussion with our international partners, both ESA and Japan and our Russian space station partners, because a lot of those technologies revolve around keeping crews safe and healthy and productive on the long journey to Mars. A lot of those technologies and techniques are being tested on the International Space Station. Right now that we're in the middle of this one-year crew mission, we've just passed the halfway milestone on that. Again, lots of pieces needed for the long journey to Mars. Many of them are either being designed or technologies being demonstrated for, and others are on the way. But this is going to be a long duration endeavor. We're going to have to pace ourselves, particularly given where we are budgetarily. This is an expensive proposition. But yes, we're thinking ahead, and I'd encourage you to read the Journey to Mars document that you can find on nasa.gov. It expresses our latest thinking on what those major pieces are, and in particular, what we want to accomplish around cislunar space in this proving ground era through the 2020s with multiple flights of SLS and Orion, so that we can convince ourselves that we're ready for the future journey to Mars.
Thank you. Another question.
We have several that have come in on social media. The first is from @LaunchComplex, who asked, does the Orion service module include any new technologies not seen in previous spacecraft?
It's always a big question, what is a new technology? I would say the essence of the European service module is that we have a good mixture of what we have flown already in terms of concepts, in terms of technology, and that we put together to a new mix. Just want to focus on one particular thing, which is the pressure regulation for the propulsion subsystem. We're fully building on electrical pressure regulation, which is not new in that sense. But if you see the application that we are using that for, with a pressure range of more than 400 bars down to a very small regime to operate with one system as well, reaction control thrusters, but also the old OMSI shuttle engine, the big shuttle engine. This is really a new key feature which hasn't been done in such a range beforehand. So I think you always have to select where you want to fly new technologies. We believe that we want to go as fast as possible rather than building new technologies and then potentially have delays. So we're exploiting on what we can do already today.
And I would say from the Orion standpoint, what's heritage is the shape. And coming back from a lunar velocity, that's the shape that works. But inside the spacecraft and outside the spacecraft, all of those technologies are new. We are using additive manufacturing in several places of the crew module. In fact, Aerojet Rocketdyne, who manufactures the thrusters for the crew module as well, has just released a press release that they are 3D printing all of the nozzles for the reaction control system on the Orion crew module.
Another one on social media from Marcia Smith with @Space Policy Online. How many service modules has ESA agreed to provide? Are they reusable, and how much does each cost?
So, and the current agreement, obviously, we develop the design and we deliver the first flight module. We have already agreed to start the procurement of the second item, which has to be finally confirmed by the ESA Ministerial Conference in 2016. but the plans and the confidence are high that ESA will also deliver the second module. And beyond that, we will continue to discuss. Thank you.
Any other questions? We do have a question on the phone.
Kayla, try it again. Hi, this is Calico Field with Space.com. Can you hear me?
Yes, we can hear you.
Following on that second question, can you tell us what is going to happen to this test article if everything goes well? Will this one ever leave the ground? And then which test article will be flying in 2018? Or excuse me, which service module?
First off, after the tests are complete here, parts of the European service module will go back to Europe, where they will be used for other test purposes, and the main parts here we're going to keep and we're going to send to the Kennedy Space Center for refurbishment, and we're going to use the refurbished ESA service module in a second series of structural test articles when the NASA Lockheed produced half of the structural test article arrives. So the test article behind us here is going to see a lot of use over the next couple of years. This article here will not fly. We actually have the Exploration Mission 1 flight articles under construction both here in the United States and also the equivalent European parts under construction in Europe right now.
Thank you.
All right, thank you. Any other questions? Oh, gentlemen.
Cody Zoller with NASASpaceflight.com. Does the ESA's involvement with the service module put them in a good position for an ESA astronaut to ride on a future Orion mission?
It's obviously the ultimate objective to have an ESA astronaut flying beyond low Earth orbit. And we hope that this cooperation will actually lead to having a European astronaut on such a mission.
Yes, I think it's a good statement. That we would, again, this is going to be an international endeavor on this long journey to Mars, and we would love to see astronauts from several nations be involved when we first set foot on the Red Planet.
All right, anyone else?
Hello. I have two questions. May I?
Yes,
First question. What were the most helpful achievements on ISS helping with building Orion? And the second question, what kind of materials challenges have you faced?
I would say first and foremost, the advantage of ISS is that it is an existence proof that these partnerships can work in a very large scale. In my past life in NASA, had many, many years of working on the International Space Station, and it really demonstrates how much we can do. In this case, though, this is a step forward for NASA and ESA. ESA is absolutely in the critical path. It's a very complex integration of the two portions of the spacecraft, and so it really is building on that foundation that we set in ISS. There are some technology demonstrations that we're also using to demonstrate ISS or Orion components on ISS that will be helpful for the longer term development of the spacecraft. And what was question two?
The second question was about materials challenges.
Oh, materials challenges.
Yeah.
Everything. I usually describe my day on the industry side as whack-a-mole, and that there's always something that is that is popping up. And it's when you're trying to, I think Oliver touched on it a bit, you're trying to use the best materials that you can, the best technologies that you can, but you're also holding schedule and you're holding cost, and you're trying to see how all of these pieces come together. Additive manufacturing is a great example. We have several places where we utilize it, but in a broad form, it's not well understood because you don't have material properties tests of some of those end item materials. If you've actually printed an aluminum part or a titanium part, you don't necessarily have the years and years of use of that material that tells you its strength, its elasticity, and all of the things that our designers really rely on to build a safe design. So that has to be developed along the way as you go in the engineering process.
Any other questions on the phone? No? Online? One up front, this gentleman.
Hi, I'm Bob Tremblay. I'm a volunteer NASA JPL Solar System Ambassador. I blog for the Vatican Observatory Foundation, and I'm a member of the Warren Astronomical Society. I'm wondering, this may be related to her materials questions, how are you handling the radiation environment, like cosmic rays, when it comes to long-term journeys to Mars?
Yeah, several different factors. First of all, and you're right, radiation, when we leave the protective region around the Earth, becomes more challenging. So all of our avionics components, our electrical parts, they have to be radiation hardened. And we also have to take care of the crew. So one of the special features, we have to take care of the human beings on there. One of the special features we're building into Orion is we're building places that can protect the astronauts, the crew, from radiation should we have a solar flare or something like that. And we do it since mass and weight is so important. We can't build unique structures. We design the layout of the spacecraft to provide certain areas where the crew can, if you will, hide from the radiation and protect themselves from the radiation if we get into that kind of event. So we consider the avionics and the human beings.
And I'm just curious how many of your engineers play Kerbal Space Program?
I'm sorry?
I wonder how many of your engineers play Kerbal Space Program?
I have heard it described, so I can at least say more than zero. Do I understand it? Not a clue. That's right.
Any other questions? Well, then this concludes the question and answer portion of our program. I would like to thank each of our panel members for joining us today and for traveling many miles to be here at Plum Brook Station. And I think a round of applause is in order for them. Our panel members will now depart the stage, and they'll be available for a brief period of time for additional questions and answers over by the NASA meatball on the wall. And for those members of the audience who are interested in touring the Space Power facility, if you can proceed down the center aisle, and you'll be met by Space Power facility personnel who will begin your tours. And that concludes our program. So thank you very much for coming. Safe travels.